Hello everyone. In this module, we will learn about electronic configuration. Having understood the basic structure of atoms, we can now proceed to understand the electronic configuration of an atom. And what is electronic configuration? It is the arrangement of electrons in an atom. So let us try to understand it. If you remember the Bohr's model, we learned that electrons moved around the nucleus in a fixed orbit. Scientists established that electrons are confined to regions of space called principal energy levels or shells, and each shell can hold 2n square electrons, where n is natural number 1, 2, 3, 4, etc. It's very simple. Let's try to understand it. So what it says is, in the first shell or the principal energy level outside the nucleus, we will have 2 into n is 1. So 2 into 1 square, 2 electrons. So there will be only 2 electrons revolving around the nucleus in the first orbit. The second shell can have a maximum of 8 electrons because n here is 2. So 2 times 2 square is 8. Similarly, the third shell outside the nucleus will hold 18 electrons. It is 2 into 3 square, which is 2 into 9, 18. And finally, the fourth shell will have 2 into 4 square, which is 2 into 16, 32 electrons. And these shells have traditional names. The first shell is called K shell, the second is called L, the third is called M, and the fourth shell is called N shell. Further, these shells are divided into subshells called orbitals, which are designated by the letters SPDF. So you had K, L, M, N as shells and SPDF as orbitals. So if you remember from the last video, the electrons were moving around the nucleus in these orbitals. There is nothing to confuse. The broad structure is the shell, and within the shell we have orbitals. Also, if you will see, the first shell has only one orbital. So the shell and orbital are same there. In the second shell, we will have one 2s orbital and 3 2p orbitals. We have one s orbital per shell. Then we have set of 3 p orbitals from shell 2, which is L and above. And we have set of 5 d orbitals per shell from the third shell onwards, which is M and higher. With a lot of quantum mechanics involved, scientists have been able to give us some visual representation of these shells. So you look at the first s orbital in blue, it is only one orbital. There's a set of 3 orbitals in p, and there are a set of 5 orbitals in d. Similarly, we have 7 orbitals for f. So now if you imagine all these orbitals overlapping in the space and you look from outside, it will look like the quantum wave equation model. So that was just to help us visualize the structure of atoms. Now that we have understood the concept of electronic configuration, let us move forward and try to write the electronic configuration for few elements. Here we would deal only with principal energy levels, that is shells. Let us begin with hydrogen. We know that hydrogen has only one electron. The only electron will go in the K shell. We know that helium has 2 electrons, and both of these electrons will go in K shell. Now let's move forward to lithium. We know lithium has 3 electrons. So the first 2 electrons will go into K shell, but the third electron will now move to L shell. As we know, K shell can accommodate a maximum of 2 electrons as per 2n square rule. So the third electron will go to the L shell. Let's move to beryllium. It has 4 electrons. The K shell again will have a maximum of 2 electrons, and the other 2 electrons will go to the L shell. Similarly for boron, K will have 2 and L will have 3 electrons. For carbon, K will get 2 and L will get 4 electrons. For nitrogen, K will again take 2 and L will take 5 electrons. In oxygen, 2 electrons will go to K shell and 6 electrons will go to L shell. For fluorine, 2 will go to K shell and 7 electrons will go to L shell. Finally, neon will have 2 electrons in K shell and 8 electrons in L shell. Now, if we move forward to sodium, it has 11 electrons and it will again have 2 electrons in K shell, which is the maximum number of electrons that K shell can hold. Here, even the L shell will have only 8 electrons because as per 2n square rule, L can have a maximum of 8 electrons. So the 11th electron will now go in M shell. Similarly, we can write down the electronic configuration for other elements as well. Now that we know how to write down the electronic configuration of elements, let us try to understand few important terms. Valence shell. It is the outermost shell occupied by the electron. So while filling the shells, the shell which takes the last electron becomes the valence shell. Similarly, valence electrons is very simple. It is the number of electrons in the valence shell of an atom. And what is its significance? These electrons are used to form chemical bonds and are crucial in chemical reactions. And what is valency? It is the combining capacity of an atom of the element, and it is measured by the number of hydrogen atoms with which it can combine. The valencies range between 0 and 8. Helium, argon, neon, etc., the so-called inert or noble gases, have no combining capacity and hence they are regarded as zero valent element. Valency is always a whole number. With this, we can conclude our module on electronic configuration. In the next video, we will discuss chemical bonding.